Hello, my name is Jagger, and this is the second lab interactive presentation video, whatever you want to call it. But to start off with, I'll say the experiment was a success, but it wasn't a complete success. So to elaborate on that, this right here, this is the final solution that is mixed. And it's supposed to have a bluish greenish color tint to it, but as you can see with mine just looks very much like I poured pop in there. But to show you and just to prove that I did the experiment myself, I'll go ahead and I'll mix these two solutions real quick. And then before I do that, some X factors that I had with this experiment is, first of all, I don't have, as of right now, I don't have direct access to like beakers and flasks and graduated cylinders, so I use these cups from Walmart, and both cups are 651 milliliters. That was the size, and I tried my best eyeballing the measurements and everything, but as you can see, it was still a success. And then with the solution A, with the vitamin C, I know that in the video that we were watching, you're supposed to get the tablets, not the vitamin C chewables, and unfortunately I could only find the chewables, so I just used those. And as you can see, after you filter it all through, in the video you're supposed to have a clear solution, but with mine you can see it just has the slightest yellowish orangish tint into it. And then another factor that played into the experiment is that I don't think I completely filtered all of the cornstarch out of this solution, so I did the best of my abilities with all the resources I have. So to do this, so we'll start with pouring solution A. I'll put a little more. So you have that solution A right there, you have about that much in there. And then solution B, so I'll just another quart. And let that sit. And as you can see right now, it's still clear. So I just want to see how long this one takes, because this one, granted, this one was also relatively warm because I stuck this one to like boil it in the microwave and everything. This one changed probably within, honestly, 20 seconds. But again, he said in the video, temperature does play a part into how fast the color changes. As you can see right now, it just turned to a very distinct yellow color. And now it's still changing. But I just did this just to show that they'll be similar, and just to show that I also did it myself, so I can get the credit for this experiment. We'll put that to the side and let that do its thing. And then the main reason why this is called a clock reaction is due to the amount of time that elapses before the solution changes colors. So as you can see, again, I'll just use this as an experiment, because on the video it was a very light yellow on this video, to be precise, but now you can see it's starting to turn into a very golden brown, almost a caramel color. And then whenever you mix these two solutions, they react together. That cause two separate reactions, not just one, it causes two of them. And then these reactions will compete with each other, trying to push one thing out of the way or the opposite way. So for instance, hydrogen peroxide. This wants to oxidize the I- back into the I2, while the acid from vitamin C in solution A wants it the opposite way. It wants I2 to go back into I-. And then whenever you mix both of these to get this one right here, and again, you can see it's still changing colors over time, the vitamin C is consumed by the hydrogen peroxide, which then both of these solutions, they then become trioxide. The reaction happens very quickly. Obviously this one isn't as quick as this one, but you can now see that they're very, very close to color. This one's still also very bubbly because it's still halfway warm, but you can see that my experiment was a success, but I had some factors that I had to play into it. I kind of had to improvise and make do with all the resources that I have at my disposal as of this moment. So thank you for watching. I hope you enjoy.